Good morning, everyone. I'm Sai Chandra, and today's topic is protection of UPFC and Interline Power Flow Control Operation. Introduction. Let us discuss what UPFC means. A Unified Power Flow Controller is an electrical device for providing fast-acting reactive power compensation on high voltage electricity transmission networks. Protection of UPFC. We all know that the protection of UPFC can be done mainly by uh, turning off the gate pulse of GTOs. Uh, when the line current is increases rapidly, that is above the critical level under fault condition, it is necessary to divert the current from the series converter. Okay, and then the bypassing of the converter is done in within microseconds. And if the fault is in a transient if the fault is a transient fault, then the thyristor bypass switch opens when the current drops and the normal operation can be resumed. And if the fault is of a long duration, it is necessary that to initiate the closing of a mechanical bypass switch which is located across the primary winding of the coupling transformer in order to relieve the loading on the thyristor bypass switch. Once the primary bypass switch is closed, then the reinsertion of the series transformer is required. The series converter during the startup has to drive a current through the primary winding of the series transformer that matches the line current. And when the match is achieved, the current in the mechanical bypass switch reduces to zero and it can be opened without creating any transients. And the startup can be achieved in few cycles after clearing the fault. The current through the shunt connected converter under is carefully controlled under normal operating condition, and it could exceed the critical level under fault condition. So the protective action under such condition is to interrupt the normal gating sequence, and generally it is done through under transient condition. It is possible to return to normal operation within a cycle. Interline power flow controller. An interline power flow controller consists of a set of converters that are connected in series with different transmission lines. The objective of interline power flow controller is that this controller is to address the problem of compensating a number of transmission line connected at a substation. The application of TCSC results in the reduction of the net series reactance of the line. The interline power flow controller, in addition, provides the facility for independently controllable reactive compensation of each individual line, a capability to direct transfer or exchange real power between the compensated lines. And this is achieved by coupling the series connected VSCs in individual lines on the DC side and by connecting all the DC capacitors of individual converters in parallel. An IPFC with two converters compensating two lines is similar to a UPFC in that the magnitude and phase angle of the injected voltage in the prime system can be controlled by exchanging real power with the support system. And the main basic difference with the UPFC is that the support system in the latter case is the shunt converter instead of a series converter. The series converter with the prime system is termed as the master converter, while the series converter associated with the support system is termed as the slave converter. The master converter controls both active and reactive voltage, while the slave converter controls only the DC voltage and the reactive voltage magnitude. This is the basic representation of IPFC, where two lines are considered with series impedance. Now let us derive the equations. The received power and the injected reactive power at the receiving end of the prime line 1 is expressed by the following expressions, that is the P1 and Q1, where del 1 is equals to theta 1 minus theta 2, and correspondingly sin phi 1 is equals to Vp1 divided by 2b sin del 1 by 2. P10 and Q10 are the power and reactive power in the line 1 when both Vp1 and VR1 are 0. When both Vp1 and VR1 are 0, the equation are given as P1 naught and Q1 naught is same as shown in the equation. Similarly, the equations to the support line 2, that is, except that Vp2 is not independent, it is related to Vp1 by the equation. Therefore, Vp1 into I1 plus Vp2 into I2 is equals to 0. The above equation shows that Vp2 is negative if Vp1 is positive. With resistance emulation, we have Vp1 is equals to minus R1 into I1 and Vp2 is equals to minus R2 into I2. Substituting the equation, we get the constant involving R1 and R2 as R1 into I1 square is equals to minus of R2 into I2 square. The constant equation can limit the utility of IPFC. In such a case, an additional shunt converter will be useful. Thank you.